Okay, we are continuing with next talk. Our next speaker is Peter Canik. He will talk about gathering log information and putting them into database. Go on. Možete zatvoriti vrata gore, molim vas, samo ulazna.
Okay. Hi, I'm Peter Canik from Hungary, community manager at Balbit, syslog-ng's upstream developer. I'm doing packaging, support, and advocating of syslog-ng. So first of all, what is logging? It's a recording of events on a computer, like the log message on the screen. This one is from SSH. You will see on a Linux machine, you will find these under the var log directory. So what is syslog-ng? It's an enhanced logging daemon focusing on central log collection. But it not only collects syslog, but any other kind of data, log data as well. It can also process and filter these messages, and while it still can collect messages to a central location, there is also an emphasis right now to support more and more destinations like databases and recently some big data destinations. It's getting a bit like C3PO, the protocol robot, but we are still far from communicating in 6 million communications format. We are working on it. So how can syslog-ng help with big data? There are three major ways. Syslog-ng can act as a data collector, as a data processor, and it can also filter the collected data. Let's look at these in more detail. First of all, syslog-ng can collect log messages. Not just system messages, but application messages as well. And this can provide quite useful contextual data for either side. It can collect from many different kind of platform-specific sources like devlog, journal on modern Linux systems, or Sun streams on Sun machines, and so on. As a central log collector, it supports all kinds of syslog protocols, the legacy, which is still the most used syslog protocol, the new RFC 5424, and in all kinds of UDP, TCP, and encrypted versions. And syslog-ng can also collect data in many ways from applications through reading log files, collecting messages through sockets, pipes, or even application output. The next step is processing these log messages, and the advantage of syslog-ng is that processing can be distributed and done close to the source of the messages, as this processing can ease filtering and lower the load on the central infrastructure. Syslog-ng can classify, normalize, and structure log messages with built-in parsers. It can also rewrite messages. You don't have to think about falsifying log messages, but for example, there are many situations when one needs to anonymize log messages. Also, reformatting of log messages can be necessary and can be done by syslog-ng. For example, if a specific analysis software needs a different date format or needs data in JSON format and so on. And syslog-ng can also enrich data. For example, using GeoIP can find the geographical location of IP addresses from log messages, or based on the message content, it can create additional name value pairs to the log messages. Data filtering has two main uses. The first one is to throw away surplus log messages. For example, you don't want to store all debug messages, or it's also used for message routing. So you send only your login events to a CM system, or to sort log messages to different files. You also use filtering. There are many possibilities for filtering. It can be based on message content or message parameters, or based on the fields extracted from the log messages. One can use comparisons, wildcards, regular expressions, and many different filtering functions. And any of these can be combined using Boolean operators. Finally, you can forward. You can save your log messages or forward to one of the many big data destinations. Right now, the syslog-ng core supports distributed file systems like Hadoop, NoSQL databases like MongoDB or Elasticsearch, or messaging systems like Kafka. But we also have something called the syslog-ng incubator, where we collect experimental modules. There we also have support for AMQP, ZeroMQ, and some other interesting technologies. Next, I would like to talk a few words about the actual log messages. If you are running Linux, like I suppose most of you do, log messages under varlog look something similar. It's a date, a host name, and some kind of text. If you look at it more carefully, you see that the text part is an English sentence with some variable parts in it. It's quite easy to read by a human, but once you have a server or many servers, it's very difficult to find information in it using scripts or using the command line. There is a solution for this problem. It's called structured logging. In this case, we don't log long English sentences. Instead of that, events are represented as name value pairs. For example, an SSH login can be described as a bunch of fields like the source IP, the application name, and the username. The good news is that syslog-ng supported name value pairs under the hood right from the beginning. As for filtering and so on, these name value pairs were in heavy use. Data, facility, priority, program name, process ID, and so on, all were represented inside syslog-ng as name value pairs. And parsers inside syslog-ng can also turn unstructured log messages and some of the structured data as well into name value pairs. Let's look at these parsers. The first one is JSON. The JSON data is structured right from the beginning. and syslog-ng can interpret it, parse it into name value pairs. So the values inside the message can be used for filtering or to use only part of the name value pairs in the, for storage and so on. The next one is the CSV parser. Originally it was for comma-separated values, but practically it can process any kind of columnar data into fields. The most used parsing is for Apache access log. You can see a configuration sample for this one. Those are with capital letters are the fields for the Apache access log. And if you look at the line, the second line from the bottom, you will see that the username is used for naming the file where the log messages are saved. The most interesting parser is the pattern DB parser, as this one can extract useful information from unstructured log messages into name value pairs, and it can also add fields based on the message text, or if you used log check on a Debian system, you will also appreciate that it can do classification for you. Of course, to get it working, you also need XML files describing your log messages. We have some example databases on GitHub. Here, coming back to my favorite log example, the SSH login, you can see some fields which are extracted from the log message directly, like the username and the source IP, and some fields which are based on the message content, like that it's a login and that it's a failed login. And at the end, it can be classified as a violation. We have one more parser which is in our development branch. It's the key value parser. So if you have a log messages which like many firewalls do have, that there is a field name equals something, like also here on the screen, this can be parsed with syslog-ng, and you don't even have to write a parser, just send your messages through the key value parser, and you will have all the fields from that log message. There are many regulations, especially here in Europe, but also around the world, which are related to privacy. Like in PCI DSS for banks, you are not allowed to store credit card numbers in, anywhere outside the system, not even in your log messages. Or in Europe, there are many regulations that IP addresses, usernames cannot be stored. Syslog-ng can help you locating this sensitive information and overwrite it with something. There are multiple ways doing it. One can use, for some data like IP addresses or credit card numbers, one can use regular expressions, which is not really efficient. It's quite slow. On the other hand, it also works on unknown log messages. If you use pattern DB from my previous side, that only works when you know your log messages. On the other hand, it's extremely fast. Anonymizing log messages can also be done multiple ways. You can simply overwrite it with a constant like XXX or anything, just to overwrite the sensitive data, but you can also use the hash of the original data. This is a one-way function, so you cannot find from the hash the original information. On the other hand, it is pretty useful in log analysis, as you can still follow the sessions in your log data, as a single IP address or username is always the same. It always has the same hash, so you can follow the users or source IPs in your data and create sessions. The primary language of syslog-ng is C. This is why it can be quite high performance and provide much better event per second in log collection and log processing than any logging software written in interpreted languages. On the other hand, not everything is implemented in C. And also, rapid prototyping is much easier if you use one of the interpreted programming languages. That's why we started to add language bindings to syslog-ng. Right now, mainly on the destination side, but also in the development branch, we have also for some parsing. Python and Java are already in the official syslog-ng core, and Lua and Perl support are in the syslog-ng incubator and will be merged into syslog-ng most likely later. In all cases, the interpreter is embedded into syslog-ng, so it's not a separate process, which makes proper error handling possible and also easier to handle any kind of data between syslog-ng and the scripts. The big data destinations in syslog-ng are developed in Java, as most of big data is also written in Java. In some cases, C or Python implementations, client implementations are existing, but Java is the official and maintained, best maintained client implementation in most of the big data world. Getting started with Java-based destinations is right now a bit more difficult as the C-based destinations, as jar files necessary and also the build tools are not yet in most of the Linux distributions, but there are many third-party repositories with full big data functionality. When it comes to syslog-ng configuration, the first advice I always give is don't panic. Syslog-ng configuration looks quite ugly at first sight, probably even at the second one. On the other hand, it's quite simple and logical once you understand the basics of it. It's actually a pipeline model. You have many different building blocks like sources, destinations, parsers, and so on. And this can be connected together with log statements into a pipeline. I will show a simple configuration here. It starts with a version number. you can also have some includes. SCR stands for syslog-ng configuration library. So, for example, we have a ready-made configuration snippet for finding credit card numbers using regular expressions and so on. Next come some global options like how often we write messages to disk, or what do we do with host names in log messages, or many others. On the top of the screen you can see some source declarations. System source is for making configurations portable, as it hides platform-specific details from the users. So you don't have to make a different configuration for Journal or Devlog or a FreeBSD or a Solaris machine or AIX, as the system source hides all of these system-specific details and collects all of the platform-specific log messages. The internal stands for syslog-ng's internal messages. The next one is network source. It's a UDP source. Here come two destinations. The first one is a traditional file-based destination of var log messages. The next one is for Elasticsearch, and with using this configuration, you can easily analyze your log messages using Kibana. Here come some filter and parser declarations. You can see in the middle that different filtering functions can be combined using Boolean operators. Here is at the bottom you can see path for pattern DB XML file, and here is the most important part of the configuration is the log path. The first one is storing local log messages to a file. You can see that there is a source, a filter, and a destination, like in a pipeline. And next is a bit more complex, as there are multiple sources, a filter, a parser, and an Elasticsearch destination. And with this simple configuration, you can already send your messages to Elasticsearch and create some nice graphs like this one. Here on the right-hand side, you can see a table with IP addresses parsed from SSH messages, so you can see where are your users coming from and which are the top connections. Kafka is another very popular big data destination recently. It's publish-subscribe messaging, and it's the data backbone for many data-driven organizations. It's used, for example, by LinkedIn or Spotify or just about everything. There is a Kafka destination already in syslog-ng. Actually, there are two, and there is a third one in the works. The official one is written in Java. There is a C implementation in the syslog-ng incubator, and someone is working on a Python version. And hopefully by the end of this summer, we also have a Kafka source, so we can not only publish messages to Kafka, but also subscribe to messages from Kafka. At the end, I would like to summarize how syslog-ng benefits your big data infrastructure. First of all, it's high performance and it provides high performance and reliable log collection. It can greatly simplify your logging architecture, as you can use a single application for both for collecting system and application data, and the resulting data is easier to use, as log messages can be parsed and presented in a ready-to-use format, and this one together with filtering can also lessen the load on your central big data infrastructure. If you want to join the community or simply just try syslog-ng, it's part most of the different Linux distributions. But the central hub of information for us is syslog-ng.org, or source code is on GitHub, which is also used for issue tracking. We have a mailing list as well, and if you need some real-time help, you can join us on IRC on Freenode. Do you have any questions?
Okay, the question about two things. One is the pattern DB, I think you call it, which matches the regular expression. What happens to the messages which do not match any of your regular expression? Do you still have them in some separate queue where you can post-process them later? And if you missed some of the types of the messages which you would like to put?
Actually, it works the other way around. So if pattern DB matches log message, then it will mark that it's a matching. There will be also a name value pair with the rule which matched the given log message, and you can also give a classification, or actually here I don't know how much you can read from this. It's also the ugly but useful. It's the XML file describing an SSH log message. So here you can see SSHD. In this line, this one is the actual parser. So you can here see the fixed parts like accepted, and next the kind of parser you use for a given field, and the name. If you want to use the given field for later on, you can give it a name. And here, next, you can see a sample message and some sample values, so you can verify that your that the rule is correct. And at the bottom, there are some additional name value pairs which were added based on the message content.
And another question, I had a problem with load. What happens when there are too many messages coming to syslog? I had about, it said it will pause and will continue logging when the load drops. So is there some workarounds for that, where there is many incoming messages to syslog-ng? Can it queue them if the processing load is too high, or
on the sending side there is this buffer. So if there is
on the receiving side.
On the receiving side, as it's a multi-threaded application, it can scale as long as you have additional CPU cores. It can scale, and also if we come back here a bit, I didn't explain the flow control stuff here. That's if the server side feels that it's a bit overloaded, it can slow down the receiving, which will, on the other hand, slow down the sending part. So messages won't overload the server as it will be queued on the sending side.
Thank you. No more question? More?
Now that everyone is using systemd, there is already a logging functionality implemented in systemd, known as journal-ctl. What do you think is the future? What do you think is going? And now, if you install syslog, you're basically mimicking already pre-installed in the system function. What do you think is the future of syslog now?
journald is collecting log messages locally. The main feature of syslog-ng is central log collection. Also, with syslog-ng, there are many parsing, filtering, and so on possibilities, which, as far as I know, are missing from journald. And also, we can connect to many different systems. In this presentation, I emphasized big data, as this is our latest technology, but we can connect to many different kind of databases, to key value stores like Redis or Riemann, which are not really possible with journald as far as I know. So it acts as a as a message processor and router.
Okay, thank you very much. One more question.
Hi. So I wanted to ask you, if you store all these messages indexed into fields and you store them in Elasticsearch, that takes quite much of resources, like a bunch of disk space and RAM. So do you use this only for visualizing like last month of logging or longer periods?
It all depends on your use case. What I see often that people send log data into Elasticsearch, but only for a short period of time, as it's really resource hungry. But for long-term storage, they keep storing messages to flat files or flat files formatted with JSON, so you have the structure kept.
Okay, thank you very much.
Thank you.